Welcome to Ship It, a podcast about ops, infrastructure, and Kubernetes. Today we are at KubeCon Cloud Native Con EU 2022, talking to Adolfo Garcia Veitia about securing Kubernetes releases. Adolfo is a staff software engineer at ChainGuard and one of the technical leads for SIG release, meaning that he helps ship Kubernetes. You most likely know him as Puerco and have seen firsthand his passion for securing software via SBOMs, Cosign, and Salsa. Puerco's love for bikes and ChainGuard are a great match, just like Fastly and Changelog. Fastly makes all our episodes available to everyone all around the world with minimal latency. If you have content, functions, or simply want secure edge locations, Fastly.com can help you too.
What's up, shippers? Adam here, and I want to tell you about one of our new partners for 2022, MongoDB, the makers of MongoDB Atlas, the multi-cloud application data platform. MongoDB Atlas provides an integrated suite of data services centered around a cloud database designed to accelerate and simplify how you build with data. Ditch the columns, the rows, once and for all, and switch to the database loved by millions of developers for its intuitive document data model and query API that maps to how you think and code. When you're ready to launch, Atlas automatically layers on production-grade resilience, performance, and security features so you can confidently scale your app from sandbox to customer-facing application. As a truly multi-cloud database, Atlas enables you to deploy your data across multiple regions on AWS, Azure, and Google Cloud simultaneously. You heard that right. You can distribute your data across multiple cloud providers at the same time with a click of a button. And the next step is try it today for free. They have a free forever tier, so you can prove to yourself and to your team that the platform has everything you need. Head to mongodb.com/changelog. Again, mongodb.com/changelog.
We are going to ship in 3, 2, 1.
I'm so happy to be welcoming another Ship It fan on Ship It today. Welcome, Puerco.
Hey, Gerard. I'm a super big fan of your show. I've been a fan of some of the Changelog podcasts over the years, mostly Go Time, and now Ship It for.
So I'm curious, what difference does this podcast make for you?
So, right now I'm working mostly in securing workloads for open source, but before that I used to be an DevOps engineer and mostly dealing in how to build and ship software. So it's just fit perfectly for me, hearing about what other people are doing, some cool tools, all of that.
And does it resonate with you? Like, do you find like it's something that it just relates to your maybe past work and somewhat your present work as well?
Yeah, absolutely. So much about DevOps and shipping software is about the human side of things. So hearing people actually doing that in the trenches is really helpful.
Okay. Did we cover any topic which you found controversial?
Yeah, well, coming from Kubernetes, I did not share the idea of storing PostgreSQL in the local file system, but
okay.
Everybody does it their own way, right?
Where would you store it? I'm curious.
I don't know. I don't know which problems you had at the time. I don't know what kind of load do you have it under, but I don't know. I usually used to rely on the cloud providers' volumes, but it seems that you want to. This is another part that I admire of your setups, that you always want to get them ready to be easily movable to anywhere. So that's one way of doing it, but maybe some of the other offerings would add too much complexity, so we had to do it.
Well, we talked in episode 50 how we actually moved to a managed PostgreSQL, so that has happened. We also migrated off of Kubernetes, like to a PaaS. Yes. That was a bit crazy, but we had to get good reasons for that. We talked again in episode 51 how to use the PaaS better. And there's like a couple more coming, but I think Kubernetes will have its comeback. And I think PostgreSQL, we will finally move to like a properly managed distributed one. It could be Fly, it could be somewhere else, but somewhere that we can connect from multiple compute or runtimes, whether it's Kubernetes, whether it's a PaaS, whether it's wherever the app runs, it can connect to the PostgreSQL instance, which is distributed, which may be just the PostgreSQL protocol. So we don't know. But we'll see. But there's like a lot. You're right. That was a very controversial, even like for many people that I talked to, they was like, why are you doing that? You just generated so many questions. So one more question, last one about the podcast, and then we'll move on. What topics would you like to listen on Ship It? Are there any topics that you would enjoy us covering?
Right now, I'm really interested in seeing how some of the stuff we are going to be talking about gets adopted by people and hearing about the challenges they're going to be facing. Some of the tools we're going to discuss today are becoming like really quickly the standard for securing some of the workloads.
Right.
So I work on the open source projects behind these tools, and I will be really interested in finding out the challenges or difficulties or any suggestions that people may find. So if you can have people working on that and sharing, would be a great asset.
I'm thinking exactly the same thing. So I'm really glad that you're confirming that is a good idea and we should do more of that. Specifically supply chain security and all like the container and the configuration security as well. How do we sign them? How do we verify them? All those topics. We'll dig into them in a few minutes. But first, we are both going to KubeCon EU. How amazing is that? Like, it's been my first conference, like in person, in like 2 years, maybe 2.5 years. And I'm so excited.
Yeah, I mean, it's going to be incredible because we did have an in-person KubeCon in LA, but attendance was still low. It was weird because you were doing your talks in huge rooms and with very few people in them. But we missed a lot of friends in KubeCon. So I'm hoping that this one will return closer to the glory days of past KubeCons.
Yeah, I mean, again, an in-person conference and KubeCon. Yes, I'm just so excited. So excited.
Yeah, absolutely.
Now, I'm very excited to meet you. Which people are you excited to meet? Apart from me, we've already established that.
I mean, for example, I've been working for several years now with several contributors from Kubernetes from Europe and India, which I've never met in person before. Mm-hmm. So I'm really excited to have a chance of meeting them. Some of the release folks back there and, well, lots of other people from Kubernetes. Even some from the Americas didn't make it to the last conference back in LA, and I'm really excited to meet them.
Have you checked the agenda? Do you have any talks or any events that you're keen on joining? Well,
I am going to do some volunteering for manning the SIG store booth. So I also have 2 talks. So I expect my schedule to not allow me this time for attending a lot of the sessions. So I'm more expectant of the chance of meeting everyone on the events after the sessions. I'm trying to be also a track host for some of the talks of some of my friends, for example, in SIG security, and I'll be helping more than attending this time.
Right. Okay. Now, I did check the agenda. I have noticed your 2 talks, and I have one important question. Is your content ready yet? Are you finished with the slides?
Ready?
You know what conferences are like when people, exactly, that's the answer. No. Like, no, you're finishing the slides like a day before, right?
Okay. Exactly. And it's mostly because I'm still working on the demos. We are working on a lot of cool stuff for the Kubernetes supply chain and the release process. So I'm still trying to finish some features I'd like to demo. And once I know what I can show, I'll do the slides.
Okay.
I have a long flight in front of me, so I have time to do them.
That's exactly what I would expect to happen. You know, like you're just like still figuring these things out. So what are you working on right now? And Adolfo or Puerco, which one do you prefer?
So right now, we did a demonstration of the SBOM tools. SBOM is Software Bill of Materials that we built for Kubernetes during the KubeCon in LA. So those tools have become more sophisticated in the 6 months that just passed. We now have the ability, for example, to attach multiple, to split SBOMs into micro SBOMs. So for example, an SBOM is a list of materials and assets that you release with your software. It can list, for example, source code, container images, binaries, everything that you put out as a software release is listed in there. And usually you will find that you get like a huge list of everything which you download and use. But now we've been focusing on splitting the SBOM into micro SBOMs, which you can store right beside the images, for example. So instead of having one central SBOM, you will have the contents of the image stored inside of the registry. And we now are working on the tools to pull those together, and that you can present a central view of all of the information in separate SBOMs in one central place. Then we just finished signing Kubernetes. There will be some demos about those signatures, how they're structured, what information you can get from them. And if I have time, I will also like to show some of the provenance attestations that we publish with the Kubernetes releases, but we'll see.
Mm-hmm. Okay. So there's 2 talks that you're giving. One is just you. You're talking about make the Kubernetes supply chain work for you. And I'm very curious to dig into what does it mean for it to work for me or for a listener. And the second one, you have a talk which is being co-presented with you, Carlos. You're both from ChainGuard. There's Sasha from Red Hat and Steven from Cisco. And that one is releasing Kubernetes less often and more secure. I love that. I love that title. It's a great one. So I'd like to dig into the first talk first. And I think a lot of things that you're mentioning, the tooling and the demo, I think it applies to the first talk. Is that right?
Yeah, exactly. So yeah, my talk would center on those tools, on how. So most of the tooling that we've built for Kubernetes, and also some of the tools that we in turn use, like all of the 6 tools for container image signing, are not specific to the project. So you can download all of the SBOM tools that we have and produce your own SBOMs. We have release tools to sign and publish on GitHub your artifacts. Mm-hmm. So we have a couple of those, and I'll try to present a coherent story of how to put all of those together so that you can also use them in your project. That's the first one.
I'm wondering, can you give us a really quick tour? Let's imagine that I'm producing some software and it has some container images that I'm releasing, maybe some manifests, I don't know. As a quick summary, what are the tools? How do I use them? What does the process look like in a few minutes?
So I think I'll center the talk on how to do your release using, probably GitHub Actions, and then pulling some of those tools together. And so you would get, for example, the first thing that you build your project and produce the bunch of container images and binaries. And then you can produce the bill of materials, the SBOM for your project using our tools. Then using our tool, you can attach that SBOM to the images. Mm-hmm. Then you use cosign from Sigstore to add a signature to those. And time permitting, we'll see how to produce an attestation summarizing everything that you run and the outputs you produced. Okay. So that's basically the gist of it.
So the tools that you use to create the SBOMs, what are those tools? What are the names?
Well, it's a project called BOM, just bill of materials, BOM. Mm-hmm. And it's a tiny tool that we derived and produced from all of the libraries that we built into the Kubernetes release project. So back 2 years back, when we decided to give Kubernetes releases an SBOM, a lot of work went into producing that. So we thought, okay, this is software that it's worth releasing for other projects to take advantage of. And it's been doing well. We have gained some external contributors into the project. Right now, it's incubating. The tool itself is incubating in the Linux Foundation ACT workgroup, which is automating compliance workgroup in the LF. And it's been adopted by other projects. For example, I just helped one of the Istio maintainers to produce the Istio bill of materials using the Kubernetes tool. So it's nice to see that cross-project collaboration going on where we do the effort, other people can take advantage, and they, in fact, in turn, they contribute back to us with patches and also learning.
So this tool, I'm imagining it's a CLI. It's a Go-based CLI. And you pointed to a container image, to a registry, to a binary. What do you point it to and what happens next?
There are several ways that you can run it. You can point it to source code directories, and it'll produce an SBOM of those, including the dependencies that it finds. You can point it to container images, and it has support, for example, going inside of the container images, and it has support for listing the packages that are installed in the images, the operating system packages. You can point it to single files, for example, producing SBOM listing all of your binaries. We use that for Kubernetes. And it also has support for other not as widely used artifacts, like, for example, image archives. And I hope I can finish this one for KubeCon. We are also adding support to indexing inside of the operating system packages. So say you point the tool to an RPM or a dev or an APK file, and it'll list everything inside of it.
Okay. Out of all the different artifacts that it supports, which one was the hardest one to implement?
Container images.
Container images, okay.
Yeah, they're more complex. They are nested. It's an artifact that it's nested in the sense that it has layers. It has file system inside of those layers. Those file systems can be layered on top of each other. And then you have the operating system packages inside of that. So it's a multi-dimensional thing inside of them.
Okay. And do you see just the name of packages, or do you see more details about those packages? Like name of maintainers, email addresses, licenses? Like how much detail do you get in the SBOMs when they're produced?
Well, it depends on the artifact. For example, when you run it against Go modules, it will fetch the dependencies. It will take licensing information. So it has a classifier that tries to run through the licensing files it finds and recognize which license it does. So you get that information in your SBOM. Maintainer support, I don't think it's already there. So we need to add the name of the maintainer of the Go modules to the SBOM. I don't remember if we have that in Go modules. I will have to check. And then, for example, when you go into a container image, you get the name of the operating system packages that it finds inside of the layers. You get the version. Licensing information is not yet extracted, I think. And yeah, you get the nice structure about how the container image is built, layers, and then inside each of the packages.
Okay. This is an obvious one, but I think that many are thinking the same thing, which is, why is this important? Why is having this list of dependencies and all those details important?
That's the purpose of the SBOM. So when let's say that you have an incident inside of your system. So some companies run really complex systems with hundreds, maybe thousands of workloads, and a vulnerability comes up. So I hate to pile on one, but well, we have this example right now of Log4j that recently happened, right?
Yeah.
So it turns out that companies have a hard time knowing what's running inside of their computer systems, and they have a hard time knowing if they have a hard time knowing what's running, they have an even harder time knowing if those workloads are affected by a certain vulnerability. Mm-hmm. So the first step to knowing that is producing the information to know what's running where. And that's where the SBOM comes in. So for example, if you had your workloads completely covered by SBOMs and describing all of the dependencies that you have, you could simply go and query those SBOMs and find out what is running where. And you could take action based on that. And SBOMs also help you doing other things, like, for example, licensing, compliance. Right now, focus has been, since the executive order to harden the nation's cybersecurity came out last year, a lot of focus has been put on SBOMs and the way they are produced, consumed, and how tools play with each other.
Okay, so those SBOMs, when they're used with containers, they end up being added to the container image. And then I think you mentioned cosign from Sigstore being used to sign those container images. Before we go to cosign, those SBOMs, they're like spread across hundreds, maybe thousands container images. How can an organization see what dependencies they have from those SBOMs if the SBOMs themselves are attached to all those images? And then the question becomes, well, what images are we running? Is there like a centralized place where those SBOMs can be added for an org for them to see, okay, these are all the images, these are all the SBOMs? Because I imagine there'll be like a lot of duplications. Or is that maybe too far in the future, what I'm thinking?
The past 6 months or so, people were focusing more on how do I write an SBOMs? How do I actually get the information? There's still lots of debate going on the right way to produce an SBOM. So what is the true nature of the information on an SBOM? There's debate going on. But the past 6 months have been mostly about organizations focusing on producing SBOMs because others will start at some point demanding them from them. And the tooling to use them is starting to emerge right now. Some of the, known security tools out there are already able to consume those SBOMs and ingest them and analyze and allow you to take action and do a little bit of policy around them. But it's still the early days on how you can do it. There are some of us, like the company I work in, it's one example, who are thinking about the problem, trying to come up with solutions to actually make them more usable and easier to work with.
This episode is brought to you by our friends at Fire Hydrant. Fire Hydrant is the reliability platform for every developer. Incidents, they impact everyone, not just SREs. They give teams the tools to maintain service catalogs, respond to incidents, communicate through status pages, and learn with retrospectives. What would normally be manual, error-prone tasks across the entire spectrum of responding to an incident, they can all be automated in every way with Fire Hydrant. They have incident tooling to manage incidents of any type with any severity with consistency, declare and mitigate incidents all from inside Slack. Service catalogs allow service owners to improve operational maturity and document all your deploys in your service catalog. Incident analytics allow you to extract meaningful insights about your reliability over any facet of your incident or the people who respond to them. And at the heart of it all, incident runbooks. They let you create custom automation rules, convert manual tasks into automated, reliable, repeatable sequences that run when you want. You can create Slack channels, Jira tickets, Zoom bridges instantly after declaring an incident. Now your processes can be consistent and automatic. The next step is to try it free. Small teams up to 10 people can get started for free with all Fire Hydrant features included. No credit card is required. Get started at firehydrant.io. Again, firehydrant.io.
So in this landscape, then we have cosign from Sigstore. How does cosign help signing images, and how does it work very roughly in terms of certificates, where they're stored, verification?
It's a good entry point. So cosign is probably the most developer-centric tool in the Sigstore set of tools. What cosign does is it will, in its thesis operation mode, cosign will allow you to generate a key pair and then sign and blob a file. But then beyond that, things start to get more interesting. So the first one is cosign is part of the Sigstore project, and Sigstore is not only just about signing. Sigstore has a public transparency log where all of the operations get stored. So while you can generate a key pair with cosign and keep the keys to yourself. You can also use your cloud's KMS system to store the keys and use them. For example, if you run workloads inside of, Google Cloud, you can store your keys inside of Google Cloud's KMS. And when you run cosign, use those to sign and continue. But then the really, really, really great thing about cosign is that it has the ability to generate ephemeral keys where you generate a key and a certificate that it's valid for a really short period of time, sign your things, and store the public key inside of Sigstore's transparency log. So whenever you need to verify that artifact, cosign can go and query the transparency log for the public key, the certificate, to verify the artifact that you just signed. And basically, it works like magic in the sense that you don't need to distribute public keys. They're just available on the cloud. Mm-hmm. And the information about all those signatures can be stored, can be attached to the container image in the OCI registry.
Okay, interesting. Where does the Sigstore transparency log run? Or in terms of infrastructure, I'm thinking, it must be a public service, right? So that anyone can connect to it. Where does that run?
Yeah, so Sigstore is a project from the Linux Foundation, and Sigstore is providing all of the infrastructure for running the transparency log. So currently, the project has an ongoing effort to get Sigstore to general availability, and some of us are working on that project to finish all of the infrastructure changes required to get the project to GA. So we have been looking at things from all the way from infrastructure to, defining all of the policies like deprecation policies, release policies. So really getting everything the project needs to get it out there. In terms of infrastructure, it runs in Google Cloud, and it has the backing of some companies that are behind it. ChainGuard, where I'm working, is one, but it also has support from Red Hat, from Google, VMware, and lots of others.
Mm-hmm. Okay. Is it a Kubernetes cluster or one of the components? Is it a Kubernetes cluster? Is it using GCS? I'm just trying to imagine it in terms of an architecture. What does it look like roughly?
Yeah, it runs on Kubernetes. The transparency log itself runs, the backend is a project called Trillion from Google, mm-hmm. which powers the transparency log. And in front of it, it has Sigstore component, which is called Recore. And Recore is the part of the project that stores and serves the information in that transparency log. Mm-hmm. So that's one. And then everything runs in the Kubernetes cluster. Then there's another component which is called Fulcio. And Fulcio, what it does is it's the certificate authority for the project. Mm. So Fulcio is in charge of handing out certificates to sign and verify all of the artifacts that you sign. And those are the two infrastructure-wise heavier components.
That sounds like a really important component in this stack, right? Like the supply chain security stack that everyone is contributing towards, or at least thinking about, but definitely being part of in different ways. I know that this becomes almost like Let's Encrypt, maybe not as big because it's, the timelines are different. Like Let's Encrypt has been around for a long time now, like many years, but I can see it becoming increasingly important. And maybe from a scale perspective, one day it could become even bigger than Let's Encrypt, because everyone has to do this that runs software. It doesn't have to be just like a public facing software. And I can see this becoming really, really important. It's almost like the modern security infrastructure or a component of the modern security for the internet. Someone described it as like the wax seal of the cloud native infrastructure. And I think that is very, very accurate in terms of, how I'm picturing it. It's so important. So like PGP, not everyone used PGP or GPG. But even that is fairly significant. But this, I think it has the potential of becoming even bigger. And I'm really excited to see where it goes. So that's why the building blocks, they have to be really solid. And, many big companies have to be involved in it for it to be successful. And I don't think there can be any one dominant player, because I think it will belong to everyone at some point, or maybe it already does.
Exactly. That's the idea behind the project. So it's not a company endorsing it. It's an open source project where lots of people can come in, contribute, and the idea is that to make it as vendor agnostic as possible. So comparing how Let's Encrypt was able to secure the web world is really appropriate and a really good analogy of what Sigstore is trying to do for the software world. The idea is that no one single organization, no one certificate authority should control that. In Sigstore, you are in control of the identity that signs your software. So one key difference is in Let's Encrypt, you proved your identity basically by showing that you were in control of your domain name.
Right.
So either by DNS or putting a special file in a predefined location, you were able to demonstrate that you own the domain, and Let's Encrypt would issue a certificate for you based on that. In Sigstore, things are a little bit different. The way it works is that you use OIDC identities to sign your software. So currently, the way it works is that when you try to sign an artifact, a cosign will ask you to log into one of the OIDC providers that it supports. So once you logged into your provider, it will start the OIDC flow and then use the identity to generate that certificate and sign your artifact. But if you think about it, one key difference here is that in Let's Encrypt, when they issue you a certificate, you are in possession of the certificate and you install it in your own web server. In Sigstore, the infrastructure to do the verification has to be carried by the public service. So the Sigstore public good service that we are working on getting ready for GA has to handle each request for verification of those certificates. So when you pull a container image and you try to verify the identity, it will go and check in the transparency log that the record exists. So that load has to be handled by Sigstore. But fortunately, there are a lot of smart people working on the team to get that infrastructure ready. And it should be, perhaps by the time you hear this, it'll be GA or pretty soon afterwards.
So for KubeCon EU 2022, that is the reference point when this will go GA.
We're trying, but we'll see, yeah.
Okay, nice. How long has this been in the works, by the way? Setting all this up, the infrastructure and solving this problem?
Okay, Sigstore has been around for about a year and a half. Quite a lot of traction for that time. It has seen out quite a lot of traction for that time. And the GA project, some of the infrastructure was already running, but then defining a goal to get it to GA and to actually having established goals, the policies, uptime, rotation of log, all of the SLAs, SLOs that we're refining, that has been in the works now for around 3 months or so.
Okay.
And it involves everything from writing the infrastructure, the Terraform, the access controls, everything.
Okay. Is there a repo that we can link in the show notes that maybe shows what this looks like? Or maybe a blog post?
I know that we open source some of the Terraform code to get the Sigstore tools. Because the idea is that you can also, everything in Sigstore is open source, right? So you can download any of the components, run it separately, or you can run the whole thing inside of your premises if you want to. So some of the work that we've been doing for GA has been open source. Some of the Helm charts, some of the Terraform was going to be open source as well. I don't know if I don't have it right here at hand, but I can certainly
that's okay.
Get it ready later.
I'm more curious about like how it all fits together, like the overview of the different components, like the architectural diagram, I suppose. That's always like, worth 1,000 words. Just understand it like at a high level and to have a better appreciation for how, I don't want to say complex, but how challenging it is to solve this in a simple way, in a way that, just makes sense and everyone agrees with and everyone says, yep, this will work. And, just basically seeing that, even for changelog, for example, I still think about the architectural diagram, which I drew, I think in 2019. And I still keep going back to that. And I wish I was able to update that. And I'm wondering, because then the questions becomes like, what tooling are you using for that? Oh, that's like a very interesting looking diagram. Like, is it ASCII art? Is it something else? Like, let me see, and before you know it, that in itself generates another conversation. But being able to appreciate just how big this thing is, I think would go a long way. That's what I'm thinking.
Yeah, I was in charge of defining the IAM and the groups and defining the part of the access to the project. So I can check with the folks running the infrastructure and see what we can get.
Okay. So the other talk that you'll be involved with, this is one that you're co-presenting, is the one about releasing Kubernetes less often and making it more secure. So I'm intrigued by both the less often part and the more secure part, but I think the more secure part, we covered it we've covered it fairly well in talking about Sigstore and bombs and cosign and the transparency log and all of that. So why releasing Kubernetes less often? What is the story behind that?
Yeah, so this talk is basically the SIG release, Kubernetes SIG release update from the lead. So during the day, I'm a software engineer at ChainGuard, but I am also one of the technical leads with Kubernetes SIG release. And this talk is going to be like our update about the work we've been doing for the past year. And one of the things we did last year was switching Kubernetes releases from 4 a year to 3 a year. And the decision was made to move it that way after one of the releases, I think it was 119, fell right in the middle of, there were race protests in the US. I don't know if it ran already into the pandemic. So it was like a really challenging one for the release team. Mm-hmm. And also we felt that the maturity of the project now would enable a more comfortable release cycle where we, instead of having a 3-month release cycle, we would do it in 4, and enhancements have more time to get to meet their deadlines, so that documents, so that features, all the bugs are in place, ready for the releases. So we decided to switch from 4 releases a year to 3, and it's been working out. This was after that long release that it proved that everybody was, in a more chill state of mind, and things work really well. It's a little bit more of a time commitment for the volunteers in the release team, but in general, it's been working well.
Okay, so going from 4 releases to 3 has been a good thing. What about going from 3 to 2? Like, if you follow the same pattern, would it also be a good thing? I'm wondering. And if not, have you talked about it? Like, why not 2 a year? Why 3 a year?
Yeah, so 2 it starts to become more difficult because if you miss your enhancement for one release, you have to wait 6 months until you see it on the next one. So it's kind of difficult to do that. The amount of enhancements going to Kubernetes releases has been increasing like quite rapidly. So slowing things down to get things right is one thing, but then you don't want to do releases that have the huge amounts of change that they may even turn out to produce problems because things have changed so much from 6 months to the next 6 month cycle.
Okay, that makes sense. So what about the support window? We had a fairly unfortunate maybe situation. I wouldn't call it like an unfortunate series of events. Let's call it that. We were running 120 and we had to upgrade. This is a managed Kubernetes. We had to upgrade to 121 within a certain time period. I think we had like 3 months to upgrade to 121. If we didn't upgrade to 121, there would be a forced upgrade for us. The forced upgrade would mean that all the local data from the host, where that worker node was running would be wiped. That was okay, but that would introduce downtime that we didn't want. So we were thinking, can we just delay this update just like for, I don't know, like another week or two? And we couldn't do that. So we were basically forced to upgrade. And we don't do in-place upgrades. We always spin the new version. We upgrade the components, like the different, like for example, external DNS we're running, Cert Manager. There are like always a bunch of updates that we pick along the way. And I know that 123, that's a big one, because that's the one that I think removes Docker shim. So luckily we didn't have to go to 123. We had 121, 122, but still for us, doing like a long blue-green worked really well in that you deploy the new one and then you start upgrading the components and eventually migrating the workload, the main important workload for us. Being forced to upgrade is really not fun. It just introduces pressure. It's just like stress. You have to move on. You have to move faster. You have to, cut some corners. It wasn't a fun experience. So I'm wondering, from a Kubernetes release team, how are you thinking about support windows for previous Kubernetes versions?
Yeah, so our policy has been to support 3 branches. So right now we just released Kubernetes 124. This is the one that deprecates Docker shim.
Oh, sorry. So it's not 123. Okay, 124. Thank you. Okay.
Yeah, so there was a communications issue back then because deprecations are announced in one release, but do not actually take place until further releases down. And I remember back then when the news went out, I think it was just someone picked it up from a release note or something.
Yeah.
That Docker shim was going to be removed and people started panicking. But the actual deprecation is now.
So sorry, do you mean deprecation or removal? Has it been removed or deprecated?
Yeah, the deprecation happened there and then the removal is now.
Okay, so okay. Yeah, that makes sense.
And if you see the actual documentation and communications around Kubernetes 124, there's a lot of things dealing with the Docker shim deprecation. So guides on how to switch your CRI, what it means, which users are affected, who isn't, who should worry. And so basically for people who are running their own instances of Kubernetes, it's more of a concern that, for example, folks who have their Kubernetes run for them, as, for example, from a cloud provider. That's the one. So so that's the way deprecations usually work. They're deprecating at some point, and the actual removal takes place some releases further down. And then we usually support 3 of the branches. So right now we release Kubernetes 124. So that means 123 and 122 are under support. And we also have a little maintenance period after we deprecate, after we end of life one of those branches. So for example, I think it was in 119 that it was already out of support and it was in maintenance mode. And that means that I think a nasty CVE came along in Kubernetes. So since it was still in the maintenance mode, we took the patch and cherry picked it to 119. But just because it was like a really, really important and critical patch. Other than that, we always keep 3 releases always under support. That means whenever the SIGs that handle the different components of Kubernetes have bugs, because actually features, we do not cherry pick them. It's only bugs and security updates to the projects. We cherry pick those changes back to those branches. And once they're out of support, they don't get the cherry picks.
So listening to you talk about that, it made me realize how much work that is. And I know it's a team of people behind this, but you do a lot of things. How do you find the time to do all the things that you do? It's not just the SIG release technical lead, did you say, or technical lead?
Yeah.
So
exactly.
You're not just the tech lead for the SIG release group for Kubernetes. You're also involved with SIG store. You're also involved with ChainGuard, and I'm sure a bunch of other things. You go for regular bike rides. How do you find the time for all those things? How does it work?
So right now it's part of my job, right? So it's much more fun and less pressuring. But before I joined ChainGuard back in January, it used to be weekends and afternoons doing it.
Wow. Okay.
I think that's the story for most Kubernetes contributors. There are some people who are paid to do the work, but Mostly it's volunteers. Even people tasked to the project inside of their companies, it's not a full-time job. But well, right now I have, so Kubernetes is one of the key projects that my company is interested in. So I get paid to contribute and have more time because I can do it in the daytime, right?
Why do you do that? Why do you give your free time for all this work?
I don't know. It's just the nerd value I get out of it. So I get excited by working on some of the problems that we work in. So I work in the Kubernetes release side of things, not in the actual code that gets shipped to people. I ensure that the code gets shipped to them. So I've been working on lots of interesting problems that I find interesting, like how do you secure things? How do you prioritize the workloads to build things faster, to ensure the integrity, to how do we verify the binaries that we put out and ensure that we do not ship a Windows binary to a Mac user, things like that. The things I like doing. So I started working on that. And then when the supply chain security world started emerging really hard last year, we started focusing our work in the sea towards securing the Kubernetes release process. And well, here we are now with this last few advances.
Okay. Out of all the things that you do work-wise, which one do you enjoy the most and why?
You mean like in my day job or?
Well, it can be both day job and in your free time, but like all like work-related activities that you do, like all the projects that you're involved with, all the things that you do. Which one do you enjoy the most? Is it the Kubernetes release? Is it the SIG store aspect? Is it maybe something else? The one that you cannot wait to get to in a given week?
Well, the one I enjoy the most definitely is working with some of the folks in the release engineering team. So we are a bunch of contributors / friends / also nerdy engineers who enjoy working on that. And I enjoy very much like getting to design solutions for some of these problems and just working over the ideas with them and discussing them at meetings and splitting the problems and seeing how other people come up with different solutions and we all learn from each other. That's a more rewarding part for me. And some of those transforming solutions that benefit that ton of people downstream. So you not only get to play along with your friends, work on interesting problems and build cool stuff, but you also have like a huge impact downstream.
I can see that. People coming together aspect, people that, think alike, are like the same things, and just, the problems and the work, it just attracts them and it brings the best out in them. I can see that, and like really wanting to get together around a specific problem.
For example, the Kubernetes project to sign its container images, which we just finished, was like a really good example of that. So you have, of course, the SIG store tools, which are excellent, and you can use them to sign your workloads right now. But Kubernetes has its own set of challenges, which are, well, not baked into the tools themselves. So we had to instrument lots of solutions inside of the release process to be able to sign things. For example, problems like we have a multi-stage release process. So we build our things in one process and then promote and release them in another process. So how do we ensure the integrity and the signatures from the first one and carry the signatures to the next one? And then when we mirror things, Cosign will happily go and sign your OCI registry, but then we have mirror things. So if we point it to one of the mirrors, the others don't get a signature. So how do we replicate the signatures to the other ones? All of those problems, we broke them up in little pieces and set up and open issues, and people were coming and taking and grabbing some of those little pieces and contributing back. It was like a really, really interesting. One of the best moments in the release engineering team I've ever been involved with.
I think that just based on the last few minutes, I would really like to learn how Kubernetes gets built, tested, and released. I think that is at least an episode worth of talking about how does the machinery look like and how do you ensure that it continues working year after year for many years now. And like the releases, because the amount of contributions, the amount of people involved and companies involved is a crazy number. I know that you know it, tens, hundreds, thousands people. I'm pretty sure it's thousands of people involved with every single release. And it's fascinating to see and to understand how can you make that work long term with all the changes over the years.
It's a really wonderful process. So the way Kubernetes works is contributors merge their code into the main Kubernetes base. So release managers and go into the process, make sure some of those changes get cherry-picked back to the branches where they're needed. And when we got patch releases for the old branches, it's just a release manager goes and cuts that thing and it's done. Releasing a new Kubernetes minor version, like say 124 now, it's a huge endeavor comprised of several teams that go together and do things like the release notes, track enhancements, ensure bug triage is finished by the time, documentation, communications, the blogs, and there's a release lead that coordinates all of this. The release team is comprised of around 35 people who rotate every cycle. Right now, by the time this episode airs, the survey to be a part of the release team should be out. So if people are interested, they can apply there. It's really competitive. We of all the names that apply, we only around 13% get chosen. Mm-hmm. We of course encourage the leads to balance their team and distribute it across the globe, across gender, to get a team as diverse as we can. That's on the human side. Yeah, and on the technical side, we basically, just a super quick rundown is we build the project, stage all of the artifacts, do end-to-end verification of everything that's out there, and then we run a release process that puts it out to the registries, to the bucket, where you can download your kubectl and all of the binaries. And now we also add the security artifacts around them, like signing and S1s, all of that.
Okay.
This episode is brought to you by Sentry. Build better software faster, diagnose, fix, and optimize the performance of your code. More than 1 million developers and 68,000 organizations already use Sentry, and that includes us. Here's the easiest way to try Sentry. Head to sentry.io/demo/sandbox. That is a fully functional version of Sentry that you can poke at. And best of all, our listeners get the team plan for free for 3 months. Head to sentry.io and use the code SHIPIT when you sign up again. Sentry.io and use the code SHIPIT. And by Chronosphere. When it comes to observability, teams need a reliable, scalable, and efficient solution so they can know about issues well before their customers do. They need a solution that helps them move faster than the competition. And companies born in the cloud-native era often start with Prometheus for monitoring, which is obviously an amazing piece of software, but they quickly push it to its limits and often outgrow it. They run into issues with siloed data, missing long-term storage, and wasted engineering time firefighting the monitoring system versus delivering their application with confidence. They describe the system as a house of cards, where a single developer's seemingly benign change can overload the whole monitoring system, or they say they're flying blind because they pride themselves on making data-driven decisions, but losing visibility means they lose this competitive edge. Ryan Sokol, VP of Engineering at DoorDash, has this to say about Chronosphere, quote, "The visibility and control that Chronosphere's platform gives us to manage our observability data and costs are a game changer, especially with our unprecedented growth," end quote. Chronosphere is the observability platform for cloud-native teams operating at scale. Learn more and get a demo at chronosphere.io. Again, chronosphere.io.
I've been waiting from the beginning to ask you this. What is the story behind Puerco, your nickname, that everyone knows you by? Like, you can say Adolfo who, but if you say Puerco, everyone knows in the CNCF who Puerco is. What is the story behind that name?
Well, puerco means pig in Spanish, of course. And that's the way me and my wife have been calling each other since, I don't know, high school.
You're not calling her puerco, are you? She's just calling you puerco, just to be clear.
I call her marrana, which is female.
Really?
pig. Yeah.
Okay.
Yeah.
Okay. All right.
When the internet came around, it turns out that not a lot of people wanted to call themselves puerco, so it was free in most services. So I grabbed it and puerco
Right.
ever since.
Wow. Okay. So it's a nickname that you and your wife call each other? Oh, wow. That's crazy. Okay.
Yeah, it grew from there. Then my friends and my parents,
Yeah.
everybody started calling me like that.
That's genius. Like you found a nickname that you can get everywhere because I've seen LinkedIn, Puerco, Twitter, Puerco,
Yeah.
GitHub, Puerco. Like, okay, so I think I need to rethink my strategy because I've been trying to get Gerhard on Twitter for like maybe 10 years now and it doesn't work. No.
Yeah.
All right. Okay, so, all right. Now, do we use the name that me and my wife call one another? Now, that is a different question.
Well,
But you must be very brave to go with that. And I respect that. I really, really do. That is, I'm very glad I asked. It's a great story.
I've never been one of those people that take themselves too seriously. And
Yeah.
it's, well, in some...
Maybe that is the key takeaway from this. Like, I should take myself less seriously and pick the name that I don't think it would mean anything for anyone. By the way, I call my wife, because she's Romanian and I'm Romanian as well, I call her Urita, which means ugly, but like the female version of ugly. And she calls me Uritul, which also means like the ugly one, but the male version of that. Now, would that work? I don't know. I don't think people would know what it means, but...
Check on Twitter to see if it's available.
Exactly. I'm going to do right after we finish recording this. So, as we are preparing to wrap this up, I'm wondering, what is the key takeaway that you want our listeners to remain with from our conversation?
Okay, so main takeaways from all of this project and our experience building the signatures for Kubernetes has been, the first is communities are hard to work in at the individual speed and pace that you would like to see your work getting done. So while we would have been able to implement this really quickly from a technical point of view, we really have to take into account input from a lot of people, not just from SIG release. The effort to get the images signed had active collaboration from people from SIG security and from friends in SIG K8s infra who handle the infrastructure for the project. But also we had to put out a document, a KEP, it's called a KEP, which is a Kubernetes enhancement proposal, where you put out your idea and people comment on it, and you propose the technologies that you're going to use, and you get feedback from the community. And it took a while. We were working to get the container images signed for around 1.5 years, and it's now there. The work is still ongoing. We still have to not only optimize the signing process a lot more, this is just the first iteration of it, but we still have to sign other things, the attestations, we have to sign the binaries and other things. But I think the most important thing is that supply chain security in software is a really complex problem. So everybody who even tangentially touches software in any way has a role to play in securing the supply chain. So right now, the ways of that a supply chain can get attacked are many. While there are a lot of smart people working on the problems related to it, it still needs help from everybody in the software industry. So I think it's really important to emphasize that, for example, Kubernetes as an open source project is doing its part. So should all of the other projects play their own part. So I have some visibility to some of the efforts that are going on in other projects, and it's really exciting. The future is really promising because some projects, some ecosystems. I was just at PyCon last week working with the PSF folks who are looking into ways of how they can sign their artifacts using Sigstore. So whenever you pull from PyPI, you're going to get an artifact that is signed with cosign and verifiable. And the same thing is happening in Ruby. And there's inside of the OpenSSF, there's the OpenSSF is the Open Source Security Foundation, who oversees some of these projects. There is a whole work group dealing with how package managers will secure their workloads and make them work. And just as open source projects have to do their thing, companies have to also do their thing. And be it as an end users have to really, first of all, be aware of the risks involved in securing their supply chains. Now, companies in the US are, especially those that sell to the government, are going to face some compliance thing to improve their supply chains, and also individual developers. I was really struck at PyCon of how the individual developer doesn't have like much awareness of the risks involved when pulling a dependency you don't know nothing about. So the first thing is gain awareness of the problem. It's a complex problem. It's a dangerous problem. It's something we all have to improve. So if you consume software, try to think about the guarantees that software is giving you, about integrity, about its origins, and then do the same for the downstream consumer of your project. Give them warranties, build an SBOM, sign your artifacts, and always try to provide that awareness to both ends of the chain so that people can do that. And this is just in the software chain, right? But the problem is much more complex than that. And so, for example, we at ChainGuard have folks experience in not only software, but also on the policy side, on research, people who are experts on how and policy and how government does things. So it's a problem that it's urgent and difficult to address.
So my takeaway from your takeaway is that, first of all, I knew this was important, but I didn't know just how important it is. And we still hear about all the CVs and the various security vulnerabilities that hit different service providers. But until it happens to us, or until we're not directly involved with it, it feels like, oh, it happened to someone else and they should have done better. But we don't realize that actually it's maybe luck, or, call it bad luck or misfortune, that it happened to someone else. But next week or next month or even next year, it could be you, that you'll be part of it. So what did you do to prevent it? And if you do nothing, well, you will be less prepared when it comes, because it will come. And just as nowadays it's incomprehensible to go to a website that doesn't use a secure connection, like HTTPS, who remembers when there was no HTTPS? Everything was like HTTP. And now most of the websites are HTTPS. So you expect that to be the norm. So why wouldn't you expect that all the software that you consume and also put out there, that it's signed, that it's secure, that you know where it came from, that you know what are the building blocks, what did you put in it? And everyone should be able to do that and verify. At the very least, verify. And I know that is very simplistic, because like a couple of steps that need to happen, but take the first step. That's my encouragement. Become aware of the implications of not doing it. And then what is this first simple step that you can take in that direction? And I'm very keen to do that myself with our own infrastructure, with our own app. And because it's all open source, I'll be very happy to share that with others so that you can see what we do. And I can imagine an episode soon where we show how to do that, because it shouldn't be difficult. Like, that's the whole point. Like, the first step should not be difficult, or the next one, or the third one. But a year from now, I expect us to be in a much better place, and hopefully you too, the listener of Ship It. Anything else to add, Puerco, before we wrap it up?
If you plan on improving the supply chain security, the changelog, I'm happy to help and be around to answer any questions or even give you a hand in that if you want. But that basically wraps it up. It's just more of a call of be aware and be conscious that you are not alone. So yeah, you can be hit by the misfortune of getting attacked, but be aware that the way that you may be attacked is just by a vulnerability flowing upstream to you, from upstream to your project. So be a good player. We are, some of the open source projects like Kubernetes are putting out software and tools that can help you. And and also some commercial companies like Django are going to be releasing open source projects and also commercial projects to help in the problem. And yeah,
I'm looking forward to that as well, because I think the world is slowly moving in that direction. But the thing which I'm most looking forward to is meeting you in person, maybe the same day that you're listening to this, or the day after at KubeCon EU. If one of you that are listening to this are there, ping us on Twitter or Puerco. We already established that. That's an easy one. I'm Gerhard Lazio on Twitter, so that's like slightly longer. But we'll be there, both there, and we look forward to talking to you. Thank you very much for joining me today, and I'm looking forward to next time because I know it will be very, very soon. Thank you.
Definitely.
Thank you for tuning into another episode of Ship It. Check out our other podcasts for developers at changelog.com/master. You can connect with like-minded developers from all over the world via changelog.com/community. Thank you, Fastly, for the worldwide low-latency changelog.com. Our listeners love those blazing fast MP3s. Your beats are awesome, Breakmaster Cylinder. That's it for this week. See you all next week. As for my last thing, I'm super excited about the Ship It episodes coming up this summer. We have some great guests lined up, and I can hardly wait to talk to everyone. If you have a good ops infra story, hit me up on gerhard@changelog.com or via changelog.slack.com. You can also find me on Twitter @GerhardLazio.